I'm looking at my front window, looking at the birds at the bird feeder, and I think that'd be a cool shot. So I get my camera, has a flash on it, take the photograph, and boom, this is what I get. Not quite what I expected. Now, if any of you have ever shot with a flash, I'm sure you have photographs just like this. So the question is not how do you fix it? The question becomes how do you avoid it? Let me show you another example. This is Hannah. This is her standing in front of a mirror. Here's her reflection. And here am I standing behind her, and you can see the flash from my camera. Now just a couple seconds later, here she is again standing in front of the mirror, and there's a reflection, but there's no flash visible. Let's talk a little bit about physics, but in an understandable way. If you've ever shot pool, you'll know that a billiard ball bounces off the cushion at the same exact angle that it strikes the cushion, assuming that there's no spin on the ball. In other words, if the pool ball hits the cushion at 45 degrees, it bounces off at 45 degrees. So what does this have to do with photography and in particular lighting? Well, let's look at something. So if you look at this little illustration, let's just assume that the gray rectangle at the bottom here is a mirror that is completely flat. If we point our camera at the mirror, we see a reflection in the mirror. But how can we control what part of the scene is being reflected in the mirror? That is where physics comes in. The angle at which the camera is pointing to the mirror is called the angle of incidence. The angle from the mirror to the subject, whatever's being reflected in that mirror, is called the angle of reflection. The angle of incidence equals the angle of reflection. Let me say that again. The angle of incidence equals the angle of reflection. So what that means is if my camera is pointing to the mirror at a 45-degree angle, what I see in the mirror is at a 45-degree angle as well. If I move my camera to a 30-degree angle, what I see in the mirror is what's being reflected from that same 30-degree angle. If we look at things from the point of view of the light source rather than the point of view of the camera, it works exactly the same way. The light is striking the glass at the angle of incidence. It's being reflected at the angle of reflection. The range of what we see reflected in the mirror from our camera's point of view is called the family of angles. Study this for a second. It's very important to understand this. If we have a person who is standing inside the family of angles, we can see that person's reflection from our camera. However, if that person moves outside the family of angles, well, they're still being reflected in the mirror from someplace, but we cannot see it in our camera because it is outside the family of angles. If we have two light sources, one inside the family of angles, the other outside the family of angles, only one is going to be seen by the camera. Depending upon which one of these light sources is turned on, we're going to have two completely different photographs. We can look at the issue from a completely different point of view. Here we have one light source but three camera positions. Only one of those camera positions is going to show the light source in the photograph. Let's look at a practical application. I have a table set up and a mirror lying flat on the table. There's a camera pointing at the mirror, and there's a small light source pointing at the mirror from the other side. That light source is within the family of angles of the camera. Now please keep in mind that it is a light source that is smaller than the family of angles. So that means that when I take the photograph, look at the results. I see the small light source. It's not a very pretty photograph. The second setup is virtually the same as the first,
except rather than using a small light source which is smaller than the family of angles, I use a softbox which makes a large light source that is larger than the family of angles. Now when I take the photograph, what you see in the mirror is like a milky white lake. The photograph is the large area of the softbox. The last setup, notice that the light source is outside the family of angles. Now when I take the photograph, the light source is not visible at all within the photograph, and the reflection in the mirror is completely black. The easiest way to understand and experiment with the family of angles is to use an object that is flat and very reflective. The principles apply to other objects as well, however, but it becomes much more complex when you start talking about photographing people, because their faces are not flat. They're rounded and the light is bounced in a lot of different directions. This might be important to you if you're photographing someone who has oily skin or wears glasses. If you look at this photograph here, you can see the flash in my glasses. Now my chin is raised a little bit and the glasses are flat on my face. So the flash, which is a speed light, is reflected into the camera because it's within the family of angles. To eliminate something like that, when you're photographing someone with glasses, you can ask the person to lower their chin just a little bit, or tilt their glasses forward on their face a little bit. And if you look at the second photo, the reflection is eliminated because that's exactly what I've done.